Hello everyone and welcome back to Robotics with Om sir. So today in this video we will see overview of component which are useful in robotics projects. So I have some Arduino projects and some sensors. So let's start by taking a look at the components we will be covering in this video are Arduino Nano solder board, Arduino Uno board, jumper wires and breadboard, servo motors, 9-volt battery, ultrasonic sensor, LDR sensor, soil moisture sensor, sound detection module, relay modules, infrared module, motor driver, and rocker switch and LEDs. So let's take first component Arduino Nano and Uno board. So these are two of the most popular Arduino development board, right? So each with its unique features and advantages, and there are no disadvantages, but we can say advantages. So first board Arduino Nano is a compact, right? Is a compact breadboard friendly board. So it also contains 80 mega 328 microcontroller, and it's perfect for projects where space is limited or where you need a small form factor, where you don't have sufficient space to attach a lot of component or a large PCB boards. So despite its size, the Nano packs a punch with its 14 digital input output pins. It also have 8 analog inputs and on-mode USB connectivity for easy programming. So as compared to Arduino Uno is perhaps the most well-known Arduino board. 80 mega 328 microcontroller found in a Nano, but in larger form factor. So there is 80 mega here, also 80 mega 328 microcontroller, but in larger form factor, large in size. So the Uno is great for beginners and advanced users. Like Uno can offer a robust platform for prototyping and experimentation. So with 14 digital input output pins, it also have 6 analog inputs and USB connectivity same, but here is USB B type, and in Arduino Nano it has USB A type. So the Uno is versatile and widely supported by Arduino community. So both boards can be programmed using Arduino IDE, we know that, and offer a wide range of compatibility with sensors, actuators and other electronic components also. So whether you choose the Nano for its compact size, or you can choose Uno for versatility, so you will find that both boards are capable of powering a wide variety of projects, right? So next component, if we see jumper wires and breadboard. So if you have to talk about jumper wires and breadboard, these are essential tools for any Arduino project. Any Arduino project. For any project, we need jumper wires first and breadboard also. So the jumper wires, here you can see, are flexible wires with connectors at each end. So used to create connections between components on the breadboard or between components and the Arduino boards. So depending on which type of jumper wire we have, like male to male or female to female, we can make connections between component to breadboard, or also we can connect two components with each other. So they come in various length and types, including male to male, and female to female. So male to male wires are typically used to connect components to the Arduino board, while female to male and female to female wires are used to connect components and breadboard. So let's talk about breadboard also. A breadboard is a reusable solderless prototyping board. So here you can see this is breadboard, white color, and these are pin holes where we can attach our Arduino components. So these kind of boards are used to build and test electronic circuits. It also consists of grid of interconnected metal strips and holes. So here we can see strips and holes we have. So allowing you to easily connect components without soldering. Without soldering we can connect our component here. So breadboards are divided into sections, like some sections containing multiple rows of interconnected holes, and they come in various size and configurations depending on your project. You can purchase any size. So but the most common type is the standard 830 pin breadboard, right? So servo motors, next component. Now let's explore servo motors. These are very useful in robotics, automation and other projects. So servo motors are rotary actuators that allow for precise control of angular position. So here we are talking about angular position. If we have to rotate this motor in particular angle, I mean if we have to rotate only 45 degree, so using servo motors you can do that. So unlike DC motors which rotates continuously, you might have seen your DC motor, if you provide power supply to that DC motor, it will rotate continuously. But in servo motors can rotate to a specific angle and hold that position. So that motor can hold that particular position. If you want to rotate only 90 degree angle, it can rotate up to 90 degree angle only. So this is basic difference between servo motor and DC motor. In other hand, DC motors can run continuously provided power supply. So this makes them ideal for applications where precise movement is required, such as controlling robot arms, steering mechanisms and camera gimbals. So next component, battery. You know why we are talking about 9-volt battery also. 9-volt battery only, because it is a common power source used to supply electricity to only Arduino projects. So you might have seen most of the Arduino boards supports only 9-volt power supply. So these 9-volt batteries very useful, or very what we can say, very useful or necessary for Arduino boards. So it provides a convenient and portable power station, making it ideal for project where mobility is important or where a traditional power outlet is not available. So we can make our project what we can say mobile project. Or then if talking about voltage, 9-volt battery supplies a nominal voltage of 9 volt, right? So which is within the operating range of most Arduino board. And if we discuss about capacity also, typically ranges from, it can store from 400 milliampere to 600 milliampere. Then with battery we can get this kind of snap connector also, or sometimes you might have to do connections manually. So after that, ultrasonic sensor and LDR module. So let's talk about ultrasonic sensor first. So the ultrasonic sensor uses sound waves to measure distance and detect object in its path. So it emits ultrasonic pulses and measure the time it takes for pulses to bounce back from nearby object. So if any ultrasonic sensor emits ultrasonic waves, so those waves will strike on the object or get reflected, or we can say bounce back from that object up to the receiver. Then time taken by these waves to travel this total path, depending on the time taken by the wave, we can calculate distance of the object. So by calculating the time difference, right, the sensor can determine the distance to an object with high accuracy by calculating time difference. So ultrasonic sensors are most commonly used in robotics, we can say parking sensors and automatic door openers. So you can see by clicking on this I button also upside, I have made a separate video on these ultrasonic sensors. So ultrasonic sensors are used in robotics for obstacle avoidance and navigation. So obstacle avoidance, we can say obstacle detection. To detect any obstacle we can use ultrasonic sensors, because they'll give us the exact distance of that object from the robot. So that's why ultrasonic sensors are important. Then next component, LDR module. So the LDR, light dependent resistor module, is also known as photocell or light sensor. So it changes its resistance based on the intensity of light falling on it. In bright light the resistance decreases, while in darkness the resistance increases. So this makes LDR modules ideal for applications such as automatic lighting control, street lights and security alarms. So we can mostly, you can see these kind of LDR modules are used in street lights. Then why LDR modules are useful? Because they are used in street light and they can automatically adjust brightness based on ambient light levels. So both sensors are useful. Next, soil moisture sensors. So soil moisture sensors measures the moisture content of soil, so allowing you to monitor and control the watering of plants or track environment condition in agriculture applications. So we can detect moisture level in soil by using moisture sensor. So the sensor typically consists of two probes. See this kind of two probes that are inserted into the soil. So we have to insert these two probes into the soil to check moisture. As the soil moisture changes, so does the connectivity between the probes, providing a measure of the soil moisture. So how many connections are there between these two probes will detect the moisture level. Next component, so sound detection module. The sound detection module detects sound waves in the surrounding environment and convert them into electrical signals that can be processed by an Arduino. So these sound detection module or sound sensor can detect sound waves, and then they convert that sound wave into electrical signal, and later that signal is processed by Arduino board. So this allows you to incorporate sound based interaction into your project, such as clapping controls. So clapping controls sound activated alarms or voice activated devices. So the module typically includes a microphone and onboard circuitry for amplification and signal processing. Next, relay module. So relay module is electromechanical switch that allow you to control high power devices such as motors, lights and heaters using low power signal from Arduino. So the actual mechanism is that Arduino will send the signal to module that turn off the light, and then module will cut the main power supply. If Arduino sends the signal that turn on the light, then module will connect that power supply. So it consists of a coil which generates a magnetic field when energized, and one or more switch that open or close in response to magnetic field. So relay modules also come in various configuration, including single channel or in multi-channel also you can purchase to suit a different project requirement. Next component, infrared module. So infrared modules allows your Arduino to send and receive infrared signals. You might have seen in your remote also, remote control capabilities for device such as TV, air conditioner and other home entertainment systems. So it typically includes an infrared transmitter and one infrared receiver. So along with onboard encoding and decoding infrared signals. So with IR module you can create custom remote control, automate tasks based on infrared commands. So this is about infrared. You can understand that infrared hours are used only for remote controlling system. Then after that, next component, motor driver shield. So a motor driver shield is convenient way to control motors. Simply say motors. So if you have to attach motors to Arduino boards, we have to use motor driver shield, especially with Arduino Uno board. We have to attach this motor driver shield above the Arduino Uno boards, and it typically plugs directly into the Arduino board and provides multiple motor control channels, along with protection features such as overcurrent and over temperature protection. So motor driver shields are commonly used in robotics, remote controller vehicles and automation project. Then next component, rocker switches and RGB LEDs, you know already, switch and LEDs. So these are LEDs, and these are versatile light source capable of producing wide range of colors like red, green, blue, and they are commonly used in Arduino project to add visual feedback. So for green signal we have to add a green LED, for red we can add cancel, or any error, for any error we can add red LEDs. So RGB LEDs typically consist of 3 separate LED chips. So this is about RGB LEDs. So how to attach these components to Arduino board, we will see that in the next video, how to attach these components, how to configure sensors, and how to make use of each sensor and module by attaching it to the Arduino board, and how to write code in Arduino board using Arduino IDE, that we will see in the next video. So thank you for watching this video.